Okay, page 3 starts with problem 8. This is pulled from SAT test preparation materials. We have this equation x over 2 is equal to 4 over y is equal to 4. So we could write several equations from this. This is just showing you several different equalities. X divided by 2 is equal to 4 divided by y. It's also telling us that x divided by 2 is equal to 4. It's also telling us that 4 divided by y is equal to 4. And so we have all these different equations that we can solve. We can use these two on the right to solve for x and y. I would just multiply both sides of this equation by 2 to identify x, because then I would have 1x, which is the multiplicative identity. 1x is equal to 8. I just applied the property of equality by multiplying both sides by 2. And so x is 8, so we can put that quantity inside box A. To solve for y over here, we really don't want y in the denominator here. Or we could think 4 divided by what equals 4? Well, 4 divided by 1 equals 4. So you could just determine that y equals 1 that way. Or we could multiply both sides by y to make it show up a little easier. 4 is equal to 4y, then divide by 4 on both sides. Another way to see that y is equal to 1. But if x is 8 and y is 1, then a must be greater than b. We also should look here and make sure that we can use this to check our answer. If x is 8, 8 over 2 is equal to 4 over 1. That's true. 8 over 2, 8 divided by 2 is 4, 4 divided by 1 is 4. And you can see the cross products are equivalent, as they should be in this proportion. So answer choice A is greater than B. Problem number 9 asks, what is this form of a linear equation called? This is slope intercept form. When you have a linear equation and y has been isolated on one side of the equation, on the other side you'll have a variable term with x and its coefficient m. M represents the slope of the line. And a constant term, and that constant term represents the y-intercept of the line. Because if m is 0, if m is 0, if this, let me take that back, sorry, I'm jumping ahead. If you want the y-intercept, you want the point at which x is 0, because you're not right or left at all, you're on the y-axis. And so if I substitute 0 for x in this equation, the variable term goes away, and that just leaves me with the y-intercept b. It's asking us now to write a linear equation in this form where m is equal to 0. So if m equals 0, then that will also result in no variable term. So y will just equal some constant term like y equals 7. If I graph that line, let's take a look at that. If I have my coordinate plane, x-axis, y-axis, if I graph the line y equals 7, it's going to look something like this at the point 7. At the point at which y is 7, there will be a horizontal line, because no matter what x is, if x is 1, y is 7. If x is 5, y is 7. If x is negative 3, y is 7. And so that results in a horizontal line. At y equals 7. Now it asks us to write a linear equation in this slope-intercept form where b equals 0. If b equals 0, that means my y-intercept is 0. So if my y-intercept was 0, my line would have to go through the origin like this. Okay, so I'll just say y is equal to 2x for that linear equation, plus nothing, plus 0, because I don't have my y-intercept is 0. Then it asks, what can you say about this linear function? If the linear equation passes through the origin, it's also a proportional relationship. For example, if x is 1, y is 2, so if I write a proportion, a ratio of x to y, I could have x is 1 and y is 2. If x is 2, y is 4. Do you see how we have a proportional relationship here? The cross products are equal. It's just there's a scale factor of 2 equal to the slope. That's not true. You don't have proportions like this when the y-intercept has any non-zero value. And so this is significant when your linear equation passes through the origin. You have a proportional relationship. Problem number 10. Identify the y-intercept and slope of the linear equation below, then graph the line. This is pretty easy to do since the equation has been given to us already in slope-intercept form. So as long as we know this form, we can simply look at the equation and see that the slope m is negative 3/2 and b is positive 1. To graph the line, we would start with the y-intercept. We know that the line is going to intersect the y-axis at positive 1. And then we can use the slope to identify other points. We know that slope is change in y over change in x. And so I'll represent negative 3/2 as negative 3 over positive 2. I could also represent it as positive 3 over negative 2. I'll get different points, but they'll both be on the line. If I use this representation from my y-intercept point, I will go down 3. That's the change in y. That's the vertical change. Down 1, 2, 3. And the horizontal change, the change in x is positive 2, so I'll go 2 to the right. If I had instead thought of this as positive 3 over negative 2, that's still negative 3/2 because positive divided by negative is negative. I could have gone up 3 in y and then left 2 in x. And that point will also be on the line. The line's going to look something like this. The next question asks, is this linear relationship proportional? It does not pass through the y-axis, and so it is not proportional. And we can see that using the same method we used in the last problem. If I look at the ratio of x to y, using these 2 points, 2, negative 2, so when x is 2, y is negative 2, is that equivalent to this ratio, negative 2x for y? It's clearly not, because this cross product is 8, this cross product is 4. And so you don't have a proportional relationship if you have a y-intercept, if you have a non-zero y-intercept, if the line does not pass through the origin, it's not proportional. What is the slope of the line perpendicular to the one that we graphed? Well, the slope of the line we graphed is negative 3/2. The perpendicular line will have the opposite reciprocal slope to negative 3/2. So that would, if you think of the reciprocal of 3/2 as 2/3, you take the opposite of negative 3/2, it's positive 3/2, and you take its reciprocal, that would be 2/3. So we'll write that down, but then we'll take a closer look at that. 2/3 is the answer to this question. But let's write an equation for that line, and actually let's give it the same y-intercept. but let's give it the opposite reciprocal slope, 2/3 x. So if my other line also passes through the y-axis at y equals 1, and the slope is 2/3, I'll go up 2, right 3, or down 2, left 3. And so that line will be perpendicular to the one we graphed. To get the perpendicular line, you want to take the opposite slope, the opposite of the slope, and also its reciprocal at the same time. Okay, the final problem on this page, identify the y-intercept and slope of the linear equation below. Remember the slope-intercept form is y equals mx plus b. If you look at this linear equation, y equals -8, there is no variable term. Y never varies. There's literally no variable term, and that's why y does not vary. Y is constantly -8. There's only a constant term. B is -8, m is 0. If m is 0, then this variable term goes away in this slope-intercept form, and a 0 slope also indicates a horizontal line. So our line would be at y equals -8. It would be horizontal. And it makes sense because if x is 2, what is y? You input 2 into this function, you get -8. You input 6, you get -8. You input 0, I should say for x. If x is 2, y is -8. If x is 6, y is -8. For any element in the domain, x is -5, y -8. So that's why you get this slope of 0, because y is never varying. It's always -8. Okay, that does it for page 3 of the video. We'll pick up the review with page 4 on the next video.